Hi everyone! In this module, we'll go over the basics of conducting the mapping analysis on historical urban transformation. After completing this introduction, you will better understand the following. 1. Research resource for historical urban transformation. 2. Collection of historical maps. 3. Collection of historical orthorectified photos. And 4. Geo-reference of historical images data. Before focusing on the mapping, let's look at the research resource for historical urban transformation, which can be classified into 1. Literature, 2. Image, and 3. Site visit. First is the literature, which includes city chronicle information, such as city archives, government annual report, planning documents, such as historical master plan, planning legislation, academic literature, such as investigation report, articles with case as study areas, and news, such as historical newspaper. As the first step in the study of urban transformation, literature can help understanding the context and general content of urban development. You can collect the literature first, and then look for the corresponding information in relation to which topic you are studying, if the time is limited for the overall reading. A detailed tutorial on literature review can be found in Module A. Then second is the image data, which includes historical optical image, such as aerial satellite time series imagery, historical photo database, historical mapping record, such as historical maps, spatial temporal data, terrain elevation data, population data distribution, etc. It is impossible to study urban transformation without images data. This visual information can be sought accordingly to the topic and study area. According to the image collection and general review, we can initially set the timeline and digital platform for further mapping analysis. The last one is site visit, which includes built environment recording, such as street profile, spatial perception recording, e.g., cognitive mapping, behavioral trajectory, oral history interview, such as Aboriginal interviews, and heritage remains recording, such as specimens of architectural elements, dating of paving materials. Site visits can help us to complement the primary data and conduct more in-depth research of study areas. As it requires sufficient investment of time and financial cost, it is often conducted at last after the research topic and study area have been identified, and the first two steps of the study have been completed. In this module, we will focus on historical image data, which is the most intuitive source for urban transformation research. Here, we will make conceptual distinction between the various types of image data, describe their characteristics, and introduce the way to use them as well as their advantages and disadvantages. First are the historical photos from historical optical image mentioned above, which are visual documentation of urban physical spaces and socio-culture behaviors captured through optical imaging technologies, including silver gelatin prints, glass plate negatives, and digital imaging formats. Since its mid-19th century inception, photography has evolved into a cornerstone of urban spatial documentation, transitioning from early dry plate techniques to panoramic stitching, and now AI-enhanced digital archiving systems. The photos enable analysis of architectural details, street-level materiality, and informal spatial practices. They have advantages in capturing transient urban scenes in high-density visual archives, while having disadvantages including fragmented preservation, scale limitations, primarily microscale documentation, etc. The second is orthorectified photos from historical optical image, which are multi-temporal surface reflectance records acquired via remote sensing platforms, spanning visible, infrared, and synthetic aperture radar spectral bands. Originating from aerial photogrammetry in World War II, satellite mapping matured with Landsat's global coverage in 1972 and now achieves 0.3 meter resolution via some commercial systems. Orthorectified photos enable multi-scale urban sprawl modeling, land use transition mapping, and morphological detection. They have advantages in continental scale temporal continuity, with sub-meter precision, and disadvantages in historical data discontinuity due to the limitations in early developments. Then next is historical maps, which are systematic graphical representations of spatial cognition, including surveyed maps, schematic diagrams, and planning blueprints, shaped by cartographic paradigms and technical constraints. The development of maps aligns with humanity's techniques of world cognition, progressed from manual surveys to triangulation, photogrammetry, and digital cartography, with projections advancing from empirical estimates to mathematical rigor. Maps can reveal power dynamics in spatial epistemology and cultural ideologies. They can serve as long-term chronological coverage, complementing visual archives when conducting urban transformation research, while their symbolic abstraction limits quantitative analysis, and there are ontological biases depending on the cartographers and mapping agencies. The last is spatial data, which is georeferenced structured datasets encoding spatial information, including vector data, such as building footprints, road networks, raster data, such as DEMS, and LiDAR point clouds, etc. The spatial data advanced through GIS, 3D laser scanning, and spatial databases, enabling multiscalar spatiotemporal analytics. They can support quantitative urban analysis via metrics such as street centrality calculation, via space syntax. They have advantages of high-precision data records. While due to the time constraints on technological development, there is scarcity of historical datasets. This is all the tutorial of this part. From next module, we will learn how to prepare for urban transformation mapping analysis with historical maps and orthorectified photos.